Hi, I'm Paul Brodie. We're in my shop, Mitch behind the camera. We were asked if we would do a video on TIG welding. So I know there's other TIG welding videos out there, but I watched a few and they're welding 3/16 plate, 1/4 inch plate. Most of the welding I've done in the bicycle industry and on motorcycles, it tends to be on the smaller side, like if I'm welding up an exhaust pipe or a bicycle frame. So we're going to do a little demo here and a little explaining about what goes on in the world of TIG welding, and we're going to move over to my new bench over there. So let's go. I have two TIG welders. I bought them in the 80s, so I've had them quite a while, and they're both good welders. One is right here. This is my favorite. It's not as noisy. And this is my other one. I hide it in here. I use this one AC, so this is aluminum welding. It does steel as well, but it's kind of noisy. It's one of the older ones with the big transformer. So those are my two welders. All welders are not created equal. I've tried different welders, and often it's how it starts an arc. This one is particularly nice because it starts the arc nice and soft, and it's really reliable. It always does the same thing, and I just like how this one works. It's very nice to use. The other one, the larger one, it's noisy for one thing, so the whole shop gets filled with the sound of that big transformer, and it just doesn't quite weld as nicely. So don't think that all welders are the same. They are not. Let's take a look at the torch. I got a custom handle here. Thank you, Isaac. It's got my name on it. It's got a Canadian flag. Needs a little bit of glue because it slips back and forth a little bit, but it's nice to have a custom holder. Thank you. So this is the TIG torch. Basically, when you're TIG welding, it's electric. There's an electric arc. So let's take this apart, and I'll show you some of the things that's going on here. So this is the tungsten here. It comes in different sizes. This happens to be a 1/16 inch tungsten. Then there's a collet here. Do you see on the collet there's a split? That's what holds the tungsten. So if I just put this in my lap, so if I squeeze that, do you see how it holds and then I let go? Squeeze it. I want to show you that because what holds that is the end cap goes on and it presses. It applies pressure. So there's a little thread there. It's made out of brass, and it's a very fine thread, and I like to put anti-seize on there because it helps it not to seize up. And the reason I'm showing you this is because you don't need to over tighten this. There is no reason whatsoever to crank this down. It only has to hold the tungsten that much so that the tungsten does not move. So that's something I wanted to show you. These are the cups that go onto the end, and you can see there's all different sizes. I've got these 3 different sizes. I never use these ones. I just use this. This lets out more argon. Argon is the shielding gas. We'll get into that real soon. And on the torch itself, there's a collet holder. So this is the collet, and it goes into the collet holder. Now, I don't have the one that the torch came with. The one that the torch came with, it looks kind of like this, but there's 4 holes, and the gas has to come out, and I don't like those at all. You see this one here? It's got a fine mesh in there. It's a very fine mesh. And what this does, it diffuses the argon. So the argon comes out much more even, a much more even flow. So I highly recommend getting a gas lens, L-E-N-S. That's what they're called, and I think they're less than 30 bucks. They last a long time. If you get a lot of splatter, you can see splatter in here. Can you see that where there's little bits stuck in there? That's the only reason that eventually you would not use this and get a new one. I use a 16th inch tungsten, and I also use a 3/32 for the heavier metal. But for welding up a bicycle frame, for example, 16th inch tungsten is all you need. It's 2% thoriated, and you see the end, it's got red on it. So that's what you want for the steel. And it's also available in the slightly larger size. So when you use the larger size, you need a larger collet and you need a larger gas lens, because it all works as a set. That's probably about average. You can have it, if you have it in more, it shields better, but then it's very hard to see. So it's good to have it out somewhat. If you're welding, say, on a bicycle frame and you're welding the down tube and the seat tube, that's quite an angle. You have to you have to hang this out. Excuse me. You have to hang that out like so, because you've got to get in there. So it does work. So the argon is going to shield. So that's basically how the TIG torch works. On my welding set here that I use quite a bit, I've got my on switch here, and then I've got my welding current. So the current, I can adjust it up and down like that. It tells me how much I'm using here, although this is kind of silly in a way, because someone else would have to be looking. When I'm welding, I can't see that, so I don't know what the actual current is while I'm welding. It's got lots of other things. It's got pulse, and it's got a starting current, upslope, downslope, crater. I never use any of these. This is what I do. I switch it on, and then I set the current, and I just weld. I would say that TIG welding is probably the hardest of all the different kinds of welding to actually learn, because you're using both hands and a foot. So you have to coordinate between 3 parts of your body and your eyesight. And talking about eyesight, you really need good eyesight. These glasses that I wear, these are 1.5s. I use these for reading, computer, machining, all shop stuff. But I can't TIG weld with the 1.5s because I can't quite focus on how fine the arc is and the distance of the tungsten, that whole thing. So for TIG welding, I use 1.75s. I go up 1. So I can't overemphasize this, because I taught a few people how to TIG weld in Frame Building 101, and sometimes the welding splatter and it didn't look good at all, and so I'd question them on their eyesight, and they'd say, yeah, my eyesight's not very good. You really do need to have very good eyesight when you TIG weld. So I highly recommend maybe experimenting with a slightly stronger eyeglass. It could pay off big time. I have a bottle of Argon here, and Argon is the inert gas which shields the electrode that stops the oxygen from the air from coming in and contaminating the weld. So Argon is pretty crucial in this. So first thing you want to do when you're welding is to switch it on, and this is the gauge that shows how much pressure is in the bottle. I'm getting low, and then this here, that little ball, although now I know that sometimes they just use a gauge, but that little ball shows how much argon is flowing through the torch. I think this is CFM. When you're welding steel, I like to have it at 10. 10's good. Aluminum is 20. You can go a little higher. You can go 15 on steel, but I don't know if that's really necessary. You're just using more argon, but that's up to you. So I'm going to hit the pedal right now, and I can hear the flow through the torch, and it's right at 10. So that's what we're going to use I showed you earlier how tungstens come. They come in a, for me, in a package like so. So that's how long they are. And then you sharpen both ends. So this has its end both sharpened. You can see how this one is a little bit shorter. And then as you use up the tungsten, you can see how short they can get. Once they get to be this short, they get harder to sharpen. So we're going to go outside and I'm going to show you how to sharpen on a bench grinder. Some people use a belt sander, but I think that a bench grinder is better because the wheel has a curve to it, a radius, and so basically you get a little bit of a curve in there. When I sharpen a tungsten, I guess the best thing that I can show you in terms of the shape or how sharp the tungsten is a pencil that's been well sharpened. That's about the angle that I like. So if you keep that in mind, that's a good rule of thumb. I do not like it when someone sharpens a tungsten and it's like that. I don't think that's good. What's happening is that there's electricity flowing down, and so when the electricity flows down, how you sharpen the tungsten, it focuses that electricity. So it's important to get a nice arc. You never, if this is the grinding wheel, you never sharpen it like that. You always sharpen it straight up and down so that the wheel is coming past it like that, and the lines which it makes are the lines this way, never that way. So, and it's fairly easy to sharpen this one because I can hold it in between my fingers here, and then I can hold it against the grinding wheel, and I can turn at the bottom. When you get a tungsten this short, it's hard to do that. You've got the wheel coming down there and you're trying to get your fingers like that. So that's when you can use something like this. You can, maybe it's a little bit of cheating, but now you can just hold that against the grinding wheel and sharpen it. So let's go outside where it's warm. Right now in BC we're having a heat wave, and I want you to know that in the interest of being safe, I wore long sleeves today because when you're TIG welding, there's the UV light that comes off it, and you can get a sunburn. It all depends on the amperage. The higher the amperage, the more pronounced that becomes. So we're not going to be using that high, but I have long sleeves on because I'm trying to set a good example, and I also have welding gloves too. So let's go outside, sharpen a couple tungstens. Here's my bench grinder. It lives outside, so it's got some a patina now from rust because it's undercover, but it's outside. I've got a diamond stick here. This is used for sharpening a grinding wheel, and I've had this forever almost. It lasts a long time. So I'm going to show you, because when you sharpen a bunch of tungstens, the tungsten, it gets caught in the grinding wheel, and so after a while it's not as sharp as it used to be. So I'm going to show you how this works. Back and forth like that. It's hard to grind something really accurately when your hands are just floating around like that. So what I like to do is I like to anchor my hand against the grinder like that. I can do that. It all depends on the grinder. And then this hand is just holding the tungsten. This hand, these fingers are turning it. So what I was doing there, as I'm grinding it, I'm moving the tungsten across the grinding wheel. because if I stay in one spot, it's going to make a groove. So that's why I always keep on moving across as I'm turning. Let's try the drill now. I don't normally use this. This is a really short tungsten, but let's see what happens. So now I've got my hand here. Here's the foot pedal. This is old style. You probably won't find one like this now. They've become a lot smaller and a lot lighter. Maybe this is made better, I don't know. So when you press down, a couple things happen. It starts the arc on the electrode, the tungsten, and it also starts the gas flow, and you can set it on your machine. There's the pre-flow and there's the post-flow. Some machines haven't got as much option on the pre-flow, but you can always adjust the post-flow. I've got mine set for about 3 or 4 seconds. When I'm welding, I press down a little bit and it starts the arc, and then I can see what's going on because the arc is like a little flashlight down there. I can see where I am with the tungsten if I'm not in the right position. And then after that, I press the pedal down more and it increases the amperage. You can think of this like a gas pedal on a car. The more you press down, the more power you get. So one of the reasons I'm showing you this is because when you're welding, you want to probably be about halfway, maybe a little bit more. If you are pressed all the way down and you're just barely welding, that means that you have to switch up the amperage. And if you're welding and you're only into the pedal just a little bit and you've got lots of power, that means that your amperage is probably too high. So I like to set it so that when I'm welding, I'm about halfway, because then I can back off a bit or I can add more power depending on what's happening. When you're welding something, like if I'm welding this, you often have to press down a little more to get the heat into the metal and to get a puddle started. And then once you're making the puddle and the metal heats up a bit, you might have to back off just a little bit. It's kind of a fine line in there. And it takes a while to get sensitive with your foot to what the power needs. Okay, this is the easiest way to TIG weld, the easiest way to learn how to TIG weld. I'm sitting down, I'm on a table, the table is the right level, the table is made out of metal. If you notice, there's a ground, see I've got a ground clamp down here, so I don't have to have a ground clamp up on the table or on the workpiece. That saves a little bit of time. And you want to be comfortable, so that's why I got a couple 2x3s here. You can use a 2x4. So if I was going to weld onto this piece of metal, this is a pretty good height. And let's say I'm welding something up higher. I've got it in a vise. Let's say I'm welding this piece of metal here. That's where the blocks of wood come in handy, because I can set it up, and I've got lots more wood. I can set it up to whatever height I want. So if I'm welding this, for example, I've got the right height now. If I didn't have these blocks, well, that gets pretty, how do I get up to that height? I have to have my hands supported somehow, because otherwise I cannot keep this torch under control. So I like wood. So now I'm at the right height. Right? Actually, that's a better height, like that. So when I'm starting, and this kind of goes with what I was saying earlier, is that not all TIG machines are created equal. If I want to weld this with this, I have to start the arc. Some of the machines, you can hold the tungsten just above where you're going to weld, and the arc will start. Some machines, you'll hit the pedal and nothing happens. Sometimes what can help is if you rest the cup on the metal, that can help start it. If it's a tungsten that's just been sharpened, that's usually easier to start. If you've got a used tungsten, sometimes what helps is just I don't have my foot on the pedal, not pressing down. I just do a little scratch, and for some reason that helps. So you could try that. So there's the two things you can try if it doesn't start right away. If you rest the cup and then get the arc started, or give it a little scratch with the tungsten, that helps as well. I'll just lay a bead. I'll use the rod and I'll go along and I'll just lay a bead on top of one of these. If I lay that on this piece of aluminum, this is about 3/8 of an inch thick. This is a huge heat sink, and this piece of metal by itself, it doesn't need that much heat. So what I would do, I would raise it up on blocks, and then I would weld across like that, because then this table isn't acting like a heat sink. So what I can do is I can put that piece on there so it doesn't move as much. On the tungstens, it's been sharpened to a very nice point. If the rod hits the tungsten, you have to change the tungsten. You can't continue. Well, you can, but not advisable. You won't get a nice weld. If you dip the rod into the metal, you also have to change the tungsten. That's one of the common mistakes that a novice makes, is they keep on welding even though the tungsten looks like a piece of unsharpened something. So you need to keep your tungsten sharp. This is what I use for welding small stuff. This is basically MIG. This is copper coated. This is not copper coated. This is 045 and this is 035, and those are the two sizes of rod that I use. This is for heavier metal. For building frames, 035. So what I do is I cut off lengths. You can see how it's still curved. I cut off lengths about that long, and then I just feed it into this tube, this holder I've got. If I'm going to use it, I still plan on making a roller so that when I pull it off the roll, it comes out straight. But in the meantime, I just take my fingers like that. Can you see how it's straightening out? I don't like using a really bent rod. If it's a little bent, not bad. So can you see how that's a lot straighter than this? That's what I like to do. When you're welding, you want everything to be as clean as possible. So even though this looks pretty clean, there could be a little bit of a coating on there, so you can do different things. I've got a little bit of emery cloth here, so I just want to show you a little bit of the cleaning process. So I'll do a little sanding like that. Usually if I'm building a bicycle frame, that's all I'll do. I'll do that. But if you want to be more particular and clean it, you can use other things. So you can use acetone. Acetone is good because it dries clean. So I just sanded that. Let's put a little bit of acetone on there and see if anything comes off on the paper towel. So look, even though I sanded it, now it's cleaner. What you don't want to do is to take something like a contact cleaner or a brake cleaner, something like this. I know you think that it's cleaning it, but it leaves a residue. And what happens is when you heat that up, it can give off a gas. I know of one welder, I read about this a few years ago, and he damaged his lungs. He said that he hardly ever did this. Well, he never did this. He wasn't thinking of something. He sprayed it on there, and then when he welded over it, there was a little puff of smoke or something for only a couple seconds, and now he has lung damage for the rest of his life. So do not use anything like this. The only thing I can recommend is acetone, and don't have it near a heat source either. Always put it away from you. Okay, after all this talking, we're going to do a little bit of a weld now on this. This is 049, so it's kind of thin, but that's okay. And I'll grab one of my welding rods here. I'm going to use the 035. I'll straighten it out just a little bit. So the first thing to do is to strike an arc, and then you have to wait for the metal to melt. Because when you strike an arc, it doesn't mean that the arc is hot enough to actually melt the metal. So you have to wait. You have to have some patience. You have to wait for the metal to actually melt, and you might want to increase the foot pedal position, a little bit more heat. And then once the metal starts to melt, that's when you can add the rod. There's no sense making an arc and then trying to add metal. It's a process. You have to wait. You wait until there's an arc, a puddle, and then you can move the puddle along and add rod. So there's not a lot of space, and you need to hold the tungsten, the electrode, really close. I would say that when you're using 1/16 inch tungsten and you're working on thin metal, you should have a gap of about 1 millimeter, maybe a little bit more, but it's better to have a small gap, because what happens is you set the amperage on the machine, and so that's fixed. If you set the amperage to 50 amps, the machine, it can't deliver more than 50 amps. But what can happen is that if you lift up the tungsten and now you've got more of a space, the machine has to work harder. So what it does, it increases the voltage. So now you have a hotter arc, and the arc is over a larger area too. So there is no advantage whatsoever to raising up the tungsten. You want to keep it very close. Go along. So, put my gloves on, grab my other glasses, and we'll make a pass. I'm going to do a first pass. One thing I want to say is that at the end of the pass, I take my foot off the pedal and I leave the torch where it is, because there's what's called the post flow, and on my machine it's set to about 4 seconds, 3 or 4 seconds. If I take the torch away, what that does is oxygen rushes into that hot weld, and it could not be good for the weld. But when I leave the torch right at the end position, the argon shields it. So that's what you want to do. It's a common mistake. Like if you're brazing, for example, and you finish the weld, you take the torch away. So if you've got any experience in brazing, there's that a tendency, it's almost like a reflex, that once you've finished, you take the torch away. Well, that's not what you want to do. Here we go. Okay, so I've got a puddle. There we go. So not a real straight line, but I didn't really have anything to follow. So let's flip it over and let's see. You see how it's slightly raised up? Very, very slightly raised up. That's what you want. And then when I flip it over, you've got the penetration. It came through. If you don't see these marks on the back, that means you didn't have enough heat there. What we can do now is we can weld one piece onto another. This is the easiest welding because it's flat. It's in a straight line basically. So let's put one piece next to another and we'll do what's known as a butt weld. So what I'll do here, I'm going to put a tack weld here, and then I'll go over here and I'll start a weld and come along. See how there's a little tiny ball there and stuff like that? So that's being heated up. What's nice to do if you want to make a nicer job, you cut the end off and then you've got a brand new rod to start with. That's all. Now I'll go back over here, we'll start. Leave the torch in position. So if we look on the back, you see that's a lot of penetration. So that weld is going all the way through. What we could do is to take it over to the bench vise and hit it back and forth with a hammer and see how strong it is. Okay, so we'll give it a hit. It's not breaking. Okay. Oh, okay. It started to split. Okay. I think that was a pretty good test. I think my weld is okay. So we'll go back and we'll talk about a few more things. Angle of the torch. What is the correct angle of the torch? Well, it depends on the situation. Let's say that something like that is that about a 45, maybe 50. If you hold the torch up like that, you're putting all the heat directly into the metal, which maybe is a good thing, but then it gets hard to see because what you have to do is you've got to get the rod in there as well. And when you hold the torch up like that, what happens is the cup is hiding the electrode, the tungsten. If you angle the torch like that, what happens is the arc, the heat, is reflected off somewhat. I mean, yes, you're still putting heat into there, but so it's kind of a compromise, and it depends on if you've got to weld into an area. So, but I would say that's about how I weld, like that, and that's probably about a 45, something like that. There we go. The bottom bracket is 83 thou thick, and the down tube is 35. I measured it, it's actually 33, so you've got a difference of 50 thou. So I have to join the two. So if I put the tungsten right on the corner there, it's going to burn away this tube, or it has the potential to burn away this tube. So I need to put the tungsten below. Can you see where the tungsten is right there? It's maybe a millimeter below this down tube here. That heats up the bottom bracket and gets this warm enough so that they both come up to heat at the same time. That's important. So when you're welding a thin tube to a thicker tube, and especially when the wall thickness of the thin tube is the edge, because the bottom bracket goes straight through. This is an edge. You need to put more heat on the large, on the thicker tube away from the edge. It's important. It works like that. I got my 2x3s here, so I'm at the right height. So here we go. Just one little tack, and then I flip it round, so I gotta tack the other side as well. When you're tacking something like so, and there's an edge, and there's two pieces of metal, sometimes the arc wants to jump to the piece, and so, which is the easiest for the arc to jump to, and it jumped to this tube here. So what I wanted was the arc to go over to here, so I switch off the pedal, I move the tungsten down, and then I start up again. Because if the arc starts on this tube here, it's going to overheat, and it did overheat a little bit. I had to add a little bit of extra filler. So it's tricky when you're joining two pieces. You always have to get the arc on the piece you want the arc to be, which is the heavier one, which in this case is the bottom bracket. So we're going to switch fixtures now, and I'm going to weld around, and I'll show you something else. What I'm trying to show you here is that the tungsten is not aiming right at the very corner. It's slightly off, and it's aiming at the bottom bracket a little bit more than on the down tube. That's important because you're putting more heat into the thicker tube. Let's see what happens. And I'm going to do, on the bottom bracket, I do 6 passes. I do 1, 2, 3, 4, and then the 5, 6 is on the sides. I switch from 049, I'm on 083, so I need a little bit more power, just a little bit more amperage. Oops. What's hard about welding something like this is that your hand has to follow. So it's not going in a straight line. It has to follow the arc of the tube. And something that can help is before you weld is to just move the torch through that arc, because then it gives you like a muscle memory. You know where your hand has to go, and you know if your hand can reach the end of the place that it has to weld. That's a good thing to do, not just start and wondering if you're going to get to that position. If you go through the arc of where you have to go, then you'll know if you can do it. Okay. I haven't welded a bottom bracket for a long time. I'd say it's possible. Not perfect, but strong. So let's move on to other projects. We have a little welding project here. This is my Aramaki race bike, Aramaki. And the exhaust is basically made. I took the old mounts off, and this is going to be the new mounts. So first what we'll do is I'll take off the pipe, and I'll tack weld on the 4 corners here. When you weld on a pipe, you always weld along the pipe. You would never weld around the pipe. That just weakens it. So going to get welded there and there, and then we'll put it back on. And I made this mount here, and then it gets a little reinforcement as well. I've got a sketch, resting my hand against the megaphone here. This is my sketch. What this shows is how this mount is happening. So if you're mounting an exhaust on a race bike, this is a good little sketch to have. We have to make a little reinforcement piece that comes right down here. That's that piece right there. I'll just weld everything up now, and then we'll make the reinforcement piece and weld that on, and then this job is done. If you take a little wire brush, I like these little guys here. They're made out of stainless steel. I think they cost about $4, and they makes the weld look quite nice. Ooh. Trying to hold the tungsten really close. Last one. Thank you for watching our video on TIG welding. Hope you learned something. If you have questions, feel free to add something into the comment section below. Mitch and I like coffee. If you were to buy us a coffee, thumbs up. Until next week, stay safe, stay cool. Bye-bye.